So in this video, we'll be looking into isomerism of alkenes, and we'll be looking at the examples on the board, which is the pentene, butene, propene, and then ethene. Now look at methane. I put it in a bracket, which actually means that there's nothing like methane in organic chemistry. And then there's not like CH2 as well. So the first member of alkene is starting from ethene. So please take note. First member of alkene is what? Ethene. Okay, and before I proceed, I've made a video of isomerism of alkenes. So, and I want you to watch it because it's going to guide you on how to work around the isomerism of alkene. So this video is only for alkenes. And remember that isomerism is classified into two, which is the structural isomerism with the stereoisomerism. Remember, the stereoisomerism comprises of the optical isomerism and as well as the geometric isomerism. So for others too. So for this alkene entails structural parts of isomerism and as well the structural part and as well the geometric aspect too of isomerism. Please do well to share this video to your friends, any chemistry students, your classmates, any student you know that will actually want to learn from this video. Give us a like thumb, give us a super thanks. I think it's going to cost you maybe a little amount or maybe 400 or so. Now let's start with the first one, which is pentene. The pentene has a molecular formula of C5H10. So it has a molecular formula of C5H10. So if I draw the normal structure of pentene, that's going to give me C, 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 C. So putting the 3H here. So this one having 2 hydrogen here. So I'm having hydrogen here. And then at this place, I put my first double bond here. So this will have my H here. This will have H here. And this will have H here. This is pent 1-ene. This is exactly pent 1-ene because the double bond is on the first carbon. So this is going to be pent 1-ene, or you call it 1-pentene. Now what do I do next? The next thing for me to do is to now take note of one thing. Some people might be wondering that why is this thing, can this thing not be cis pent 1-ene or trans pent 1-ene if you are considering the geometric aspect of alkenes? Now, one of the conditions or rules that makes a compound to be in geometric form, I mean cis and trans, is that the carbon to carbon double bond, I mean this carbon to carbon double bond here. So anything attached, the molecule or the compound or anything, or the molecule, compound, anything you call it, or the group, rather, let me use the word group. So the group attached to this carbon here and also this carbon here must be two different group. Now look at this group here. This group here is H, they are the same. And even if here is H now and here is CH3, then, and also this group here, this carbon here too, it should be attached to this group and then this group. Now looking at this first carbon we have here, yes, it obeys the principle for geometric isomerism, like for you to have cis and trans, because this carbon has this hydrogen here, a group, and then this C3H7, another group. So this carbon here has two groups, but this carbon we have here, it only have one group. Like the groups, they are the same and the group must be different, which the group is just one, which is hydrogen. Though the hydrogen is so, or I think we have two different things there attached to this carbon here now, then you're going to say we want to observe our cis and trans. But in this case, you can never see any cis and trans from this pent 1-ene. So that's the first isomer. Let me name it as first. So this is the first. Now another one is that you can do it this way: CH3, then C, 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 C. If I put my double bond on the second carbon here, so I have my hydrogen here and also hydrogen here. So then I have my CH3 here. Count the number of carbon. We have 5 carbons. How many hydrogen? This is 3, 4, 5, 6, 7, 8. We have 2 hydrogen left. So I can now put one hydrogen here, then another hydrogen here. Exactly. Now let's observe the rules of that cis and trans. Firstly, the name of this compound is pent-2-ene, or you call it 2-pentene. So this is pent-2-ene, or you call it 2-pentene. So let's now observe the cis and trans from here. This carbon atom here, these are the carbon to carbon double bond, right? So this carbon atom has 2 groups, 1 and 2. That means it has hydrogen and what? And C2H5. That means 2 different groups. And this carbon here too also this one has 2 groups. This carbon here also have 1 and then 2. So it also have it has 2 different groups. So simply means that it obeys the principle of cis and trans isomerism. So in that case, we can have cis pen2-ene and then trans pen2-ene. So for you to have cis pen2-ene, take it like this. The hydrogen here must be together, like they must be on the same plane, must be together. So meaning that this compound I've drawn on the board is cis pen2-ene. Cis pen2-ene. So that is the second isomer. So that's the second isomer. Okay. So what about the trans as well? Let me draw the trans. It's still the same thing. So the trans is going to be CH3 C C C CH3. If the double bond is here, then our hydrogen is here, another hydrogen is here. So if you have one hydrogen here and another hydrogen here, so that is the trans form. That's the trans. So the name is going to be trans pen2-ene. Trans pen2-ene. And then that is the third isomer. That is the third isomer. Okay. So let's observe the fourth isomer. The fourth isomer. So looking at this, remember that if I put the next double bond here, it's still going to give me, if I put the next double bond here, it's still going to give me pen2-ene. Remember that I will start my counting from here, 1, 2. So now instead of starting it from here, 1, 2, if I should put the double bond here, so on this place, then I will start the counting from 1, 2. It's still giving me pen2-ene. If I put it here, it's going to give me pent1-ene. So which simply means that I can no longer shift or reposition the double bond again. So the only thing I'm going to do now is to break down the carbon atom into 4 and then try to put the 5th carbon here and there. So the next thing you are going to do now is to write 4 carbon, 1, 2, 3, 4. Then remember, if I put my double bond here, and have it in mind that I have I have another carbon left. So take note, if I put the carbon here as CH3, I don't want to write this. I put it as CH3. I put the carbon here as CH3. So this is still going to give me 1, 2, 3, 4, 5. So this is going to give me pen2-ene. pen2-ene. This will still give me pen2-ene, yeah. Because if I should put another carbon here like this place, so if you count the chain, it's going to be 1, 2, 3, 4, 5. So, and this double bond will still be here, and now to give me pen2-ene, meaning that we are repeating what we have done before. So then what about if I put the next carbon here? Let's see, as CH3 here. Then let me fill up the rest with hydrogen. I put hydrogen here, hydrogen here, put hydrogen here, then I put H3 here. Okay, these will have 2 hydrogen, right? Okay, so let's count the number of carbon and the number of hydrogen. We have 5 carbons there, and we have how many hydrogen? That's we have 10 hydrogen there, meaning that we are still obeying the molecular formula. the molecular formula of pentene as C5H10. But let's name this structure. If you should name this structure, this is 2-methyl but 1-ene. Is that not it? Yeah. So this is 2-methyl but 1-ene. Exactly. So this is the fourth isomer. This is the fourth isomer because it is 2-methyl but 1-ene. But look at it. Can we have the cis and trans? No, because this carbon atom we have here, and so these are the double C to C double bond. So this carbon atom here has two different group. First CH3, second C2H5. But the second carbon, this one has two. It has two different group. What about this carbon? This carbon have same, which is one. So we cannot obey cis and trans from here. All right. Okay. So if we can do that, this is 2-methyl but 1-ene, right? Good. Okay. So we can only have only the normal 2-methyl but 1-ene, no cis, no trans. Okay. So the next one we're going to have is, let's try something like this. CH3 C. I have one carbon left, right? So if I put the CH3 here, then if I put my double bond here at this place like this, I put the double bond here at this place like this, all right? Then if I fill in my H3 here, here I'm going to have one hydrogen here. I think it's still balanced. What did I do here? I only changed the double bond from this position to this position. You can see the double bond is here on this position, but in this next compound is here. So let's name that particular compound. This is 3-methyl but 2-ene. You're going to start your counting from here is 1, 2. So if you also start from here is 1, 1, 2. Better still is better for you. Okay, fine. Let's start it from here. 1, 2. You start from here. This is 1, 2. On position 3, you're going to have your methyl. But if you started from here as 1, 2, it's better for us to start it from here because it's going to help us to give this substituent closer to the first carbon and also to the functional group. Starting it from here is 1, 2. Is this one will be 3-methyl but 2-ene, but coming from here is 1, 2, and that is 2-methyl but 2-ene. It's better for us to start from here. So giving this name as 2-methyl but 2-ene. 2-methyl but 2-ene. All right. Okay. So having this now, then now let's see. Will there be cis and trans? Let's check. Will there be cis and trans? Let's check. For this is the C to C double bond. For this carbon atom, you have this a group and another group. Okay, it's obey. What about this? We have this and this. These are same group. This is one, so it doesn't obey. So we can't have the cis and trans here. We can't have the cis and trans here because this particular carbon atom here doesn't have two different group, but this has two different group. So this is going to be 2-methyl but 2-ene, and this is the fifth isomer. Now what about if I put this CH3, if I put it here on this next carbon here, naming this thing will still give me 2-methyl but 2-ene as well. Another structure we can have for this C5H10 is also 1, 2, 3, 4. So having my CH3 here, Then if I have the double bond here, and I still have my CH3 here, and I have one hydrogen here, one here, and another one here. Okay, so this is where my here will be CH2, here will be CH2, and then here will be here will have an hydrogen, and I will also have to put an hydrogen here as well. So let's look at this compound. This is the C to C double bond, right? Okay. Then how many carbon do we have here? This is 1, 2, 3, 4, 5. How many hydrogen? This is 3, 6, 7, 8, 9, 10. So you have 10 hydrogen there. So naming this compound is going to give us this is the longest chain, right? So this compound is going to give us 3 methyl, 3 methyl both 1 in. So this is 3 methyl both 1 in. 3 methyl both 1 in. That's this compound. So is there cis and trans? No. Is there cis and trans there? No. Because this carbon atom has the same group here. Why this one has different group here? It has different group here. So this is 3 methyl both 1 in, and that's going to be the 6th isomer. This is the 6th isomer. That's the 6th isomer. So no cis, no trans. And this name is 3 methyl both 1 in. So now let's move to the next carbon. Sorry, the next compound. Now look at me. In the next compound now, there's nowhere for me. I mean, there's no place I'll put this double bond again because I've put it everywhere. I've taken it from here to here to here. Then this CH3 as well. I've put it here. I've put it here. If I should put the CH3 here on this next carbon here, it's still going to give me something 2 methyl but 1 in, or probably 2 methyl but 2 in. And if I put it here, it will give me pentene or pen 2 in, or rather pen 1 in. So meaning that I can no longer put the the methyl anywhere again, and neither can I put the double bond anywhere again. So I'm done. Then the next thing I'm supposed to do is to reduce the number of carbon atom to 3. Then I'll start putting the remaining carbon atom, which is 2. If I reduce the carbon atom to 3, and let's assume I put my first double bond here, so I have 2 carbon left. Let me put the first one here and the second one here. I should name this. If you name this compound, this will still give you 2 methyl, maybe but 1 in, 2 methyl but 2 in is this compound. Okay, what about if I clean the carbon atom here? If I put it here, it's still giving me 2 methyl boats. So it'll be 2 methyl but 1 in. What about if I put the carbon atom here? C. So this is also going to give me. Remember that the carbon atom cannot be here. Yeah, exactly, because this double bond cannot have, like, this carbon atom is now going to be attached to 5 different things. So this is wrong. Organic chemistry can't be like this. So in a nutshell, there's nothing I can do again. There's nothing I can do again. Even if I put the carbon atom, this last carbon atom here, if I put it here as CH3, so this will still give me it will still give me some 2 methyl but 1 in as well. So meaning that I can't put it anywhere. So what am I going to do? The next isomer I can see from C5H10 is for me to have a cyclic pentane rather. To have a cyclic pentane. So something like this. 1, 2, 3, 4, 5. Remember that all these places represent carbons, carbon. And this is C5. Then I can now have the hydrogen as one hydrogen here, another hydrogen here, another hydrogen here, another hydrogen. I can have this, I can have this, I can have this, this, and this. And count the number of hydrogen, that is 10. The number of carbon, that is 5. So it's still giving me C5H10. And this name is known as cyclopropane. Cyclopropane. So cyclopropane, that is the 7th isomer. So that's the 7th isomer. And another thing I can have is I can still have methyl or cyclomethyl butane. Let's try to draw the structure. If I have this compound like this, then remember that I have one carbon here, another carbon here, another carbon here. So this carbon here can have the methyl of CH3. Here can be hydrogen, and also I can have hydrogen here, then hydrogen here. I can have hydrogen here, then hydrogen here, and hydrogen here. So having this now, the number of carbon there is 5, and the number of hydrogen is that's 10. So this is going to be methyl cyclo or cyclomethyl butane. Cyclomethyl butane. So this is going to be cyclomethyl butane. Cyclomethyl butane. And this is the 8th isomer. 8th isomer. Okay, what again can we do? Remember that this cannot have cis and another we didn't have trans, because looking at this compound here, this carbon atom, there's nothing like double bond here, so no cis, no trans. In this cyclopropane or cyclobutane rather, in this cyclomethylbutane, no cis, no trans. So that's the 8th isomer. And then another one, let's try if we try to work around this propane. Then we have methyl here. Then we have methyl here. So if here is hydrogen, here is hydrogen. If we have hydrogen here and hydrogen here, how many carbons do we have? We have 5 carbons. 1, 2, 3, 4, 5. How many hydrogen? This is 3, 6, 7, 8, 9, 10. That's 10. Yeah, that's 10. So we can still have something like this, and this is going to be dimethylpropane. You can still have dimethylpropane. So dimethylpropane. So this is going to be dimethyl cyclodimethylpropane. So this is the 9th isomer. This is the 9th isomer. So because we have the number of carbon as 1, 2, 3, 4, 5, and the number of hydrogen as 3, 6, 7, 8, 9, 10. So, and that is cyclodimethylpropane. Okay, looking at this, there's nothing we can do again. This does not have cis and trans because it's an alkane. It's a cycloalkane. And even if you put the CH3 here, nothing like cis and trans there. So we have it like that. And after this, there's nothing we can do again. In a nutshell, pentene has 9 isomers. Now let's look at example 2. Example 2 is butene, and butene is C4H8. So drawing the structure of butene, 1, 2, 3, 4. Okay, let me start from but 1 in first. So if my first hydrogen is here, I have 2 hydrogen here, I'll have 1 here. Then I will have 1 hydrogen here another hydrogen here, and then H3 here. So this is actually both one in. Both one in. I have here as both one in. So this is my first isomer. This is the first. And if I have my double bond here, that'll be C C C C. I have my double bond here. This is H3, this is H, this is H, and then this is H3. So looking at this, this is both two in, both two in, both two in, and then this is my second isomer. This is my second isomer. So will there be cis and trans? No, because this carbon to carbon here has different group. Okay, oh, there'll be cis and trans. There'll be cis and trans because this carbon atom here has two different group of this, and this carbon atom here also have two different group here. So there'll be cis and trans. So this particular one is cis both two in. So this is the cis both two in, that's the second. And then the next one is going to be trans both two in. Something like CH3, CH double bond, CH, and then CH3. So that's the trans both two in. Trans both two in. So this is the third isomer. So that's the third isomer. So what do you think we can do again? If I put the carbon atom here on this position, it is still going to give me both one in. So I can't even put it anyway. Then the only thing for me to do is to reduce the number of carbon atoms to 3. Then the remaining one carbon that remain, then I'll carry it everywhere. The next thing is to reduce the number of carbon to 3. 1, 2, 3. And let me put my double bond here. So if I now put the remaining carbon here as CH3, you understand? So this is still going to give me both 2 in. So I can't put it here, means I'm still repeating same thing. What about if I put it here, CH3? This is going to give me 2 methyl prop 1 in. 2 methyl prop 1 in. As you can see, if my H3 is here, then if my H2 is here, this is 2 methyl prop 1 in. So I have here as 2 methyl prop 1 in. Prop 1 in, or you say 2 methyl 1 propene, or you call it 2 methyl propene. So can I have cis and trans? Let's check. This carbon to carbon atom here we have here is attached. This carbon atom is attached to the same group, which is, let me call it 1, and this carbon atom is attached to the same group 2, also known as 1. So there is nothing like cis and trans. And mind you, if I put this double bond here, from here, if I put it here, it will still give me 2 methyl prop 1 in as well, or 2 methyl propene. So meaning that I can't go around that structure again. So what I'm going to do is that, in my video for isomerism of alkene, I made mention in there that when you have reduced the carbon atom to 3, let that be the last. Like, don't reduce it to 2 any longer. So stop it at 3. So I've reduced this one to 3, then I'm going to stop here. Now another thing to do about is to draw the cycloalkanes of this butene. So this will be the this is the fourth carbon. This is the fourth isomer. This is the fourth. This is the fourth isomer. This is the fourth isomer. You understand? So the next one is now to draw the cyclic form. So we have 4 carbons here. Then if I put one here, another one here, one here, one here, this is 4 carbon, right? Then hydrogen, 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 hydrogen here, hydrogen, 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 then hydrogen here. So this is C4H8. So this is cyclobutane. So cyclobutane. This is cyclobutane, and this cyclobutane is our fifth isomer. You know, it has 4 carbon atoms with with 8 hydrogen. So this is the fifth isomer. So the next thing I can do is that I can now reduce it to 3, something like this. This is 3 carbon, 1 here, 1 here, 1, and the remaining one I can put it as CH3 here. So put this one as H, here H, put H here, and also H here. So looking at this, how many carbon do we have? 4. How many hydrogen? This is 8. So this is cyclomethylpropane. Cyclomethylpropane. So this is cyclomethylpropane. So this is the 6th isomer. So in a nutshell, it only has 6 isomers. It has only 6 isomers. So butane has 6 isomers. Now let's go to propene. So number 3 is propene, and propene is C3H6. So during the first structure of propene, that is CCC. So what am I going to do? Then I'm just going to put my double bond here, then fill here with hydrogen. So here is H2, here is H, and that is H3. So this is prop 1 in, right? So I have this first structure as prop 1 in, or you call it just propene is allowed. Propene. So propene, and this is the first isomer. And that's the first isomer. So what again can I do? If I put a double bond here and this carbon here, this place here, it's still going to give me prop 1A. So there's nothing I can do. And I told you earlier that don't reduce the carbon atom to 2, leave it in 3. So that's all. So nothing I can do again. If I interchange the double bond here, it's still giving me prop 1A. The only thing I can do next, and then there's no cis and trans, because this is the carbon to carbon double bond. This carbon atom here has 2 groups, but this one has only 1 group. So that means I cannot see cis and trans from that. Then the next thing for me to do is to write it as cyclopropane. So cyclopropane. 1 hydrogen here, another hydrogen here, 1 hydrogen here, 1 hydrogen here, another one here, another one here. This is still C3H6, and that is cyclopropane. So after cyclopropane, and that is the second isomer. After cyclopropane, nothing again for me to do. So that is all. Let's look at the first one, which is what? Ethene. That is C2H4. So ethene has 2 carbons, which is 1, 2. Then we know that the double bond is going to be here. How many hydrogen? 4. 1 here, 1 here, 1 here, 1 here. So this is ethene, and then this is the first isomer. Now looking at this, there's nothing to do. I can't reduce the number of carbon atom. I can't carry the hydrogen, and it's not in cis and trans because it cannot be as geometrical isomer rather, cis and trans, because this carbon atom, they are the same 1. This one too, they are the same 1. So it cannot be cis and trans. It cannot exist as a cyclic ethane. It's not possible because there is no way I'm going to draw the cyclic structure. So ethene has 1 isomer, and that is all. If this video is actually helpful to you, do well to share this video, give us a like or a nice comment. Bye.